Hi everyone and welcome. Today I would like to talk to you about dependencies, configurations, packages, and drivers. So we're going to talk about how to use and troubleshoot some dependencies, gems, and drivers. We're going to talk about init.d and system.d, what they are, why we use them. We're going to talk a little bit about config files, what they are, how to modify them, and some things to be aware of, as well as starting to do a little bit more troubleshooting. So the first thing that we have to talk about is what exactly is a dependency. So the idea behind a dependency is that we have a program that is reliant on another program to run. So what I mean is, let's say we're installing program A, but program A assumes that you have program B installed. Now, this variety of dependency is actually relatively common. We'll see this a lot for saving space. We might see it for sharing code. We might also see it because it's a little bit easier for a developer to be able to say, well, go make sure you have A, B, and C installed so that you can have closer to the same setup that they have so that they have to sort of deal with less variables. Now, you should get warnings if you are uninstalling packages that are dependencies. So if you are uninstalling something that is a dependency of another package, like package B, that A is dependent on, you should get a warning about that, but not always. So it is always worth making sure that you are aware of what is reliant on other things. If you think about it like the old game of pickup sticks, making sure that the stick that you are pulling out is not actually a fundamental stick to the pile. Some packages do also like to be a primary, and that can also cause some conflicts. For example, HTTPD, the Apache web server. Um, any of the web servers really like to be the primary web server, so you do have to be a little bit careful about that when we're talking about dependencies and what's reliant on other things and sort of what wants to win for who's going to take primary top. We might also see some things like version dependencies where we have to assume that you have, for example, Python 2 or Python 3 installed. Now, this is hopefully becoming less of a problem, but Python 2 and Python 3 are not actually compatible. So like if you write something in Python 3, then you have to make sure that you are running it using Python 3. We might see some package dependencies. For example, the OpenSSH package assumes that you have libSSL installed, and if you don't, you have to make sure that you install it. It's also really common that programs will assume that you have the C libraries installed. A lot of developers really enjoy writing in C for whatever reason, and then they're going to assume that you have all of the libraries, and if you don't, that can create issues. Now, something that also has to be mentioned with dependencies is actually the security aspect that comes along with this. What I mean is, if we have, let's say, OpenSSH, and that's a package dependency of libSSL. That means we no longer are just worried about who is changing OpenSSH. We also have to worry about who is changing libSSL because we have to have both. So that means we have to worry about who's going to be making changes, who has permissions for that, what changes have gone in, and it does make it a little bit more complicated for us as admins because it ends up just extending the chain of checks that we have to do before we can install something. So if we have a program that's dependent on another program that's dependent on another program, etc., we have to go down the chain to make sure that we are able to trust everything that is going to be coming onto our servers. We have to worry about who's maintaining the code in the repository. Now, in some cases, companies will maintain it and they will just have as part of their program that they maintain some repositories. In some cases, they are open source, which means anybody could do it. There was actually a news article a few, I think, months ago where they were actually able to use the fact that people were willing to take code from others, because I mean, basically, open source is who's ever willing to work on it. You say, great, thank you for your time. because there's not a lot of people willing to work on it. So these researchers ended up actually taking some malicious code and adding it to a very well-known repository to sort of see what happens. And this ended up being problematic for a lot of reasons, but it does end up also highlighting the vulnerabilities that we have along the entire chain that not everybody necessarily thinks about. Now, we also have to talk about package management. So sometimes you'll download unpacked source code and you have to compile it before you do the install. This is what happens if you aren't pulling it from a repository. So you remember the last time we talked about repositories, installs, and updates. Well, one of the bonuses to the repository was that it's a really easy way to set up a program. Package management means that you actually have to do a little bit more of this yourself. So, for example, maybe you end up having a program you want to install. It's not actually in a repo anywhere, so you have to get the source code, compile the source code, and then install it. A lot of these programs will actually have an install file that will give you the instructions on how you are to go about doing the installation. It means that you can still install the program. There's just a couple more steps that you have to take to do it. So this is something that you'll see for either programs that aren't already accepted in repos, or maybe you need something a little bit more niche, or maybe it's something that is written in-house and you don't have an in-house repo. Any of those are possible. Now, we are going to use an example of gems. Now, the reason I'm using the example of gems is because Ruby is actually a really popular language, so it is very likely that you have already seen programs using Ruby and maybe just didn't realize it. If you ended up doing the information security course or running through my information security modules, you might have seen WordPress, and that WordPress scanner was actually written in Ruby. So Ruby Gems is the package manager for Ruby. One of the things that a package manager can do is it gives us a standard format. So the gem is self-contained. It's the same thing as a library. There's a public repository to hold all of these gems, and it's supposed to help you find them and fix any dependencies that you might have. Each gem that you want to install should have the code, the documentation, and the specs that you need. So that means rather than having to go look for things in multiple places, you have the option of just looking at the gem, and the gem is supposed to have everything. The standard format means that if you are going to be looking at one gem and then you look at another, you should see similarities in how they are set up. So it's not like you have to learn sort of a brand new way of communication every single time you want to get another gem. So this is one example of something that we will sometimes see if we are going to be installing programs on our server. And there's lots of other examples. Ruby and Ruby Gems are just a really common one. Now, the next thing that I'm going to have you do is an activity. Now, normally I would, of course, do this in class, but what I'm going to have you do instead is just pause me and try installing Tmux on your servers. Make sure after you do the install that you check it, get it running, see what's happening. If you don't understand what's going on, that's completely fine. Remember, you have the internet and you can look up what it should look like. And try it out. See what you think. And then come back and we will continue. Okay, welcome back. So next we're going to be talking about configuration files. Configuration or config files are basically a way of us being able to have programs with an initial setup and initial parameters. So sometimes we'll see config files with the extension .cnf or .conf or .ini. Those are the most common. Now, these config or configuration files are basically a way that we're able to say, this is how this program is set up by default. And if we want to make any changes to how the program is set up, we would be able to make those changes in the config file. Now, there is a caution that I would like to give you here. Config editing. You should always create a backup if you're going to modify a config file. Because a config file has all of the instructions on how a program should be working, if you modify it in a way that has an error, you can take down the program. And it can be really hard to remember which changes you've made or where exactly those changes happened. So I always recommend creating a backup if you're going to do any modifications in your config files. It's really easy to create backups. Remember, you can just make a copy of the config, cp, right at the command line. You can cat the config file into a copy somewhere. You could copy it and then only work with the copy and do something like hide or rename the original so that it's really easy to go back in and change it back, but it is something that you are going to want to think about. Now, most config files are plain text so that they are very easy to edit in any text editor. So whether you're using Nano, VI, Emacs, whatever it happens to be, it's really easy to edit config files remotely because a lot of server admins do almost everything remotely. Most config files will allow comments. Comments are how we are able to enable or disable something, and also for documentation. So for example, if we have a config file, I can comment out sections of it, and once that section is commented out, that's the equivalent of disabling that section. So if I wanted to, say, make something more permissive, I would be able to comment out some of the stricter requirements. Some config files are human readable, some aren't, some will have GUIs, but I will say really commonly you'll just have a text file. You can edit it in any text editor, work a lot with comments to disable things, and I would also advise consider using comments as part of your documentation, what you've changed, when you changed it, and why you changed it, because it's really easy to go and change a config file because you're trying to fix something that broke, and then 6 months later it breaks in a different way and you don't remember what you did. But having a comment in there, I changed this on August 1st because of this error, right by what you changed, is worth thinking about doing. Now, some configs are checked at startup, some are checked more frequently. So the current convention says that if you have RC in the name, it runs on startup. So, example, .bash rc will run on startup, whereas the etc hosts file is just checked frequently. Some configs you can also reload once you've made changes, so you can actually do things like reload the service if you made a change to the config file so that you can make sure that everything's still working correctly. Now, Init.d and System D. These are both daemons. The daemons on a Linux server is basically something that is happening in the background. It's a little bit like a process or a task happening in the background. System.d is the newer version of Init. I will say, whatever you have, you should consider working with. Don't try to switch from init to system or back. Whatever is baked into the system is probably going to be what you're going to want to stick with, because switching can create some very, very strange errors that are really difficult to troubleshoot. System.d can be used to work with services. You can use the systemctl commands. So you can use systemctl start, and that'll start a service, or systemctl stop, and that'll stop a service. So there's actually some really nice system.d commands that are very useful for working with a lot of services on the server. That's nice to be able to have. I will also say there was a little bit of a flame war and issues between init and system.d, and I've included a link if you would be interested in reading a little bit more about that. You don't have to, it's just a little bit of interesting background that if you're going to go work as an admin, it is worth knowing a little bit about, because you could very easily find yourself working for or with somebody on one particular side of that flame war. And people can get surprisingly passionate about these things. It's kind of like if you ever saw anybody get into an argument about if VI or Emacs is better. It seems like a really odd thing to argue about. It's just a text editor. They're both just text editors, but I would advise you to be careful before you step in that one. Okay. Now, the next activity that I'm going to have you do is look at your SSH config file. You probably already have SSH installed on your server. If you don't, you can go ahead and install that. I want you to go find the SSH config file, and then I want you to give a quick scan through it. Thinking about what are the important settings. Is there anything that should be changed? Is there anything that should not be changed? Is there anything that, must or must not be changed? So start reading through that so that you can start getting a little bit of an idea of what config files look like. And you can think about things like who's allowed to SSH in. Are you, for example, doing it by group or user? Are you allowing anybody to SSH in? Do you allow root to SSH in? These are all things that you can consider as you're running through your config file. Next, we can talk about drivers. So a driver is how we are able to have our hardware communicate with our software. So if you've done any troubleshooting with computers before, you've probably seen things like, oh, the driver is out of date, or oh, it's a problem with the driver. Drivers do also get blamed for some things, but if you are, for example, hooking up a keyboard and a mouse to a computer, they have a driver, which is going to be the piece of software that allows the mouse clicks or keyboard information to be sent to your system so that your system can understand it. Now, normally with drivers, they're kind of black box. They don't really tell you what's going on. You just say, okay, I'm installing it. Okay, I'm updating it. Does it work? Great, lovely. Let's move on. You can have drivers that are built separate from the kernel. Mostly your drivers come with your operating system. However, and this is a big caveat here, with Linux, there is not necessarily a guarantee that you have a working driver. So, for example, let's say we are admins on a Linux system and we want the office that we are working at to move to Linux servers. Now, this can be very useful for quite a few things, but you want to make sure that everything that you have working in the office is going to continue to work. My example here is going to be printers. Printer drivers come with what's called CUPS, the Common Unix Printing System. Those drivers either come with your operating system or are it's pretty easy to install CUPS. But if you have a printer that is not part of CUPS, now you have a problem because you have to go search for that driver. So now instead of just having a quick changeover from whatever server we had before to our new Linux server, we have to consider, does our printer belong to CUPS? If no, is there a Linux driver? If no, does this still make sense? So like, for example, one of the things that you could do is you could get a printer that is listed as being compatible with CUPS. Maybe you're due for a new printer anyway in the office, and you can just say, well, I'd like to move to a Linux server. These are our options that are compatible. Pick one of those. Sometimes that works, sometimes that doesn't. Some people might also just write a driver if you are very comfortable with programming. Perhaps that's one of the choices that you would like to make. But it is just something to think about is a lot of drivers are written for Windows systems. So once we start moving to Linux servers, we do have to make sure that there are drivers available or we get stuck writing them ourselves. Proprietary drivers are the sort of next complication on top of this. Sometimes the drivers don't come with the system. So NVIDIA, AMD, stuff like that, a lot of those tend to be proprietary. Proprietary means that it is a software program or piece of software that is owned by a company. It's not just out and freely available for anybody to be able to use. Now, some types of Linux, like Mint, have driver managers. Some are actually philosophically against proprietary drivers like Fedora, and they will actually go out of their way to make it really difficult to use proprietary drivers. Now, drivers are actually important for all manner of hardware. This isn't just printers need drivers. This is your CPU, this is your hard drive, this is your Wi-Fi card, this is all of the hardware that you need to communicate with has to have a driver. So, for example, Wi-Fi. Linux has a bit of a reputation for flaky Wi-Fi, and part of that is because of issues with proprietary drivers or drivers that are a little bit more fragile than others, or having to deal with sort of trying a bunch before you find one that works. And so Linux now has a reputation for flaky Wi-Fi because there's not a lot of drivers that sort of work out of the box for that, and it's one of the things you have to worry about if you're buying a Linux system. This is less of an issue with servers and desktops because the Linux server market and jobs is so huge. A lot of servers are actually very compatible. Server hardware is very compatible with Linux. It's just if you are trying to create a server on hardware that isn't necessarily a server hardware, you need to think about it. If the driver isn't working easily and you can't find one, your only solution might be to write one yourself. Now, if this sounds particularly unappealing to you, and I will be frank, that sounds particularly unappealing to me, what you can actually do is pick hardware based on the drivers you can find. So if you have a choice of 5 different CPUs or 5 different hard drives, and 2 of them come with drivers that you can find other people have used on Linux and it works very easily out of the box, consider just getting that instead of trying to fight with one that is, oh, sometimes it works, sometimes it doesn't, nobody said anything one way or the other kind of thing. It can be worth avoiding. Now, some troubleshooting tips. So, with all of these dependencies, configurations, some of these issues you might actually not even realize are an issue until something isn't running. As soon as something isn't running, we have to start doing our troubleshooting. So for troubleshooting, the first thing that I'm always going to tell you is read your error messages. It is very, very important that whenever your computer shoots up an error message, you just read it. Maybe it's useful, maybe it's not, but you should read it anyway. It's always worth checking your internet access, ingress and egress. That's internet coming in and internet going out. You're always going to want to check your running services. If you, for example, have something that should be running and isn't, or shouldn't be running and is, both of those can be issues. You can try looking at what's running using top. You can actually try that right now. Just type in the command top, see what happens. What are you seeing? What does this mean? You can check things like hardware usage. So, what's the disk usage, memory usage like? What other available resources are there? What's going on there? Another thing you can always do that doesn't seem to be something that people necessarily think of is check your logs. Like most programs will go right in a log. I had this problem at this time and this is the error that I'm getting. And so if you actually go through and look at your logs, you can actually find some really important information about what happened, when it happened, how often it happens, and stuff like that. You can also see if others have that issue. Is it a common problem? You know, the internet, Google is something that you can use. Don't feel like you have to know it all yourself. If you're having a problem, try Googling the problem. Is this something that a lot of other people are having, nobody else is having? And so you can start looking at your troubleshooting that way as well. You can also do things like Google your error messages, and even if it doesn't tell you how to fix it, you can at least say, oh, that error message means, because the error message isn't going to necessarily come out and say, program X crashed because. It might say something like, problem on line 352. And, well, what does that actually mean? Or, oh, EOF, I don't know what that means. And then you would be able to go look it up and say, oh, end of file unexpected. And then you'd be able to say, oh, if the end of file is unexpected, Maybe that problem is because I forgot the fi to end my if statement in this bash script, but none of those are necessarily obvious unless you've run into that problem before. So Googling the error message would be able to tell you what happened so that you can go figure that out a little easier. And then the last thing I'd like to talk about really quickly is run levels as a way of troubleshooting. So run levels are basically numbers that are associated with what's going on in the system. So we can have, for example, halting or rebooting. But one of the things that we might see really commonly used is run level 1. If we go into run level 1, this is a single user mode. So if we have sort of run through all of our other troubleshooting problems, and we don't necessarily want to take down the entire server for, whatever reason, we can go into run level 1 single user mode, and then we would be able to go and try to figure out what's going on the system. So that's sort of the step that we can take before just shutting down the entire system. But because you will be booting everybody off from their perspective, it's a shutdown. So just be a little judicious about when you use that. So that was dependencies, configurations, gems, and a little bit of troubleshooting. I hope you are all having a lovely day, and I will talk to you again later.